This is the 2009 paper. Question 1, we're looking at electron stew, a couple of constants in the first question. The Bohr model of the atom is based on several assumptions. State these assumptions and discuss their significance. So two things you have to do, and assumptions is plural, so there's multiple assumptions to deal with. So one of the assumptions of the Bohr model of the atom is that the energy levels are discrete. And what that means is they're at a particular level that is exact and specific and known, so that they, if you remember, you can draw your energy levels something like this, and they get closer and closer together. So the energy levels are very exact, very specific, at a very particular level, and the significance of that is that electrons can only be on one level at a time, one level and at a time, and never in between those points. So that's one assumption, and one point of significance. Another thing very closely related to that is that the electrons are never in between a level. They're always on one level or the other. They're never ever in between. Okay, so let's write it this smallly. Electrons always on one particular or discrete level. Okay, what that means in terms of, if you're talking about spectrum and all of that kind of stuff, there's no gradual emission bit by bit as the electron slowly rises up. It's all or nothing. It goes there, emits, well actually it's the other way, it's going down and emits a photon of light. So there's no emission of light rays, gamma rays, however you want to talk about it. Do it like that. Between levels. So it's it can't sit halfway in the middle. So your energy level and your emission spectrum is discrete as well. You can another way of looking at this, and I'm going to wrap this up because this is a pretty tricky question. It's very, very open-ended. But another way of looking at this is that what you'd expect when the electrons go from one level to another, that there's a point where it starts accelerating and increases, because remember it's orbiting, whether the shape is in a funny sort of thing like that or a circular shape, but it's orbiting. So there's a sense in which it'll have angular momentum with that circular motion, and it has to increase a radial distance. And that needs some acceleration in that direction to occur. But there's no acceleration. It just goes from there straight to there. Or while it's accelerating, there is no light emitted. So that's quite important to follow as well. Very technical, very detailed, but also very interesting when you start getting right down to it. These quantum ideas are very strange, and they don't deal with nature the way that you would expect them to, which is cool, but it's also tricky.